and welcome to another lesson for Algebra 1. We're going to be talking about ratios and proportions today. Words hopefully you've heard before, but maybe you can't define specifically. In fact, before we even get into how you deal with these kind of problems, why don't we just define what ratios and proportions are, and also what scales are. So ratios are defined as a comparison of two numbers, and some common ways that we can compare numbers is either, in a ratio, a 3 to 5, you might have heard that in gambling, or what are the odds? Well, it's a 3 to 5 odds. We could also represent that as a fraction, 3 over 5. So those are examples of ratios. Just comparing two numbers, they don't have to be equal to each other. In fact, they usually are not. Now, a proportion is usually an equation that states two examples are equal. Specifically, what about 1/2 equals 3 over 6? So these are two ratios that are completely proportional because they're equal to each other. A way you might want to visualize this is, here's half a pizza right here. And then here is a pizza that still has half pizza, but now it's cut up into sixths. So we have 3 slices left out of 6. And look, it's the exact same amount of pizza. And in fact, you might consider cutting them up like this. It'll actually might feel like it's more pizza than usual. Finally, a scale. You've probably heard of a scale before. It's typically used for not for weight, not for weighting, but instead it's in this case called about maps or ways to represent bigger situations. So a scale is a ratio of any length and a scale drawing or model to represent the actual length. For those of you who intend to be engineers and stuff like that, you most certainly want to be able to know how to deal with scales. An example of this is a scale of a map of the USA, where 1 inch on the map represents 30 miles in real life. If you want a more visual example of that, you might see this in your geography or history textbooks, where it shows the whole map of the USA, and you could tell how big the USA is by using this little scale down here. And this amount of space represents 100 miles in real life. So you can take that amount of space anywhere on the map and represents about that many miles. So let's see a few examples of how this could be used in situations. Here's an example where the sun is shining down upon a statue and a man. And the problem says a statue that is 90 feet tall casts a shadow that is 45 feet long. At the same time, a 6-foot man casts a shadow that is X feet. And we're obviously going to figure out how long the shadow is. Now, here's a little drawing. I don't want to hear your judgment, guys. I'm a math teacher and an art teacher, okay? So don't judge me too much. But here's our statue, and here's our measurements right here. And the way we figure out the mysterious shadow length, besides, just getting some measuring tape and measuring it that way, we are going to set up a proportion and figure out what that is. So remember, proportions may have two ratios. So we're going to have two fractions right here. The first fraction, what if we compare the relationship between the statue shadow right here and the statue's height? If the same light source is beating down upon the statue and the man, then the comparison of the statue and the height, the statue's shadow and the statue's height, should be the same as the man's shadow and the man's height. So now this is all set up. We can now start putting in our numbers. The statue's shadow is 45 feet long, and the height is 90. And that's equal to, well, we don't know what the man's shadow is, right? That's our whole goal, is to find out what that x is, but we know his height is 6. So now we have this equation. And some of you might already be thinking, ugh, fractions, I don't want to deal with that. Well, there's a simple trick to get rid of those fractions, and that's called cross multiplying. I can do 6 times 45 and then 90 times x and simplify it very quickly. 45 times 6, and that's equal to 90 times x. Now that we have this, guys, we can simplify this. 45 times 6 is 270, and that's equal to 90x. We're really close to finding out that man's shadow, so I'm going to divide both of these by 90 because we have 90 times x, not by 270, right? 270 is on the side by itself. We want to get x by itself. So divide both sides by 90. That cancels out on the right side. And on the left side, 270 divided by 90 equals 3. So the man's shadow is 3 feet. And if you think about this, it's very logical that the answer is this number, right? Because look at the statue. Its shadow is so short compared to its height. In fact, it's about half of it, right? Meanwhile, the man's height is only 6 feet, so of course the shadow will be smaller than 6, and it's actually half of it. So that's an example for 1. Let's do one more. This time, let's talk about using the scales of maps to figure out our problem. So it turns out if the actual distance from Chicago to Evanston is 11.25 miles, those are two places in Michigan State. And the question is, what is the distance on the map? Assuming that the scale on the map, for every 1 inch on the map, it's 18 miles. Well, this scale right here, we're going to use the exact same strategy before, guys. We're going to create a proportion to solve this because look, it's comparing the map and actual real life distance. So we know that the scale ratio represents 1 inch for every 18 miles in real life, right? So if I was going to create a proportion with 1 inch being 18 miles, then we know the mysterious inches on the map, which is x inches, is equivalent to the actual distance in real life, which is 11.25 miles. Now we have all this set up. We're not going to use the units in the future, but guys, take a look at this. Notice how the units match up perfectly? That has to happen for a proportion. Otherwise, we can't solve it. But let's go ahead and solve it now. So we're going to have 1 over 18 equals 11x over 11.25. We're going to cross multiply. 1 times 11.25 is equal to 18 times x. You notice I'm using parentheses instead of the time symbol like before, and that's fine. Now we're going to simplify this a bit more. 1 times anything is itself. So this is going to be 11.25 equals 18x. And then we just have one final step of dividing both sides by 18. It's going to give us a slightly messy number, but it'll give us 0.625 inches equaling x. Once again, notice how this makes sense if you think about it. If 1 inch is 18 miles, and this distance is less than 18 miles, then our answer of figuring out what is the distance on the map, it's going to be smaller than 1 inch. And that is it for today's lesson, guys. There's going to be one more lesson that you have to watch and do, but this is it for proportions. Guys, have a good day. Bye.